Mic check. All right. Functions. Okay, right now we've been working with one function. Did I share screen yet?
Not yet, sir.
All right, incoming.
Oh, yeah.
Everybody get that?
Yep.
Maybe?
I got it.
Okay, so far we've been working with one function. What is it? Main. Main is the main function. Main is where the program starts, at least as far as you're concerned.
I think my screen froze.
Your screen froze?
Yeah, it was minimal.
And we're back. Okay, so this is main. Right here, everything that falls in main is part of the main function. We call that the body of the function. This is the name of the function, which is just main. And this up here is the return type. And we'll talk about return types here in a little bit and explain why it's called a return type. But we saw this, right? This function can return a 0 back to wherever it was called from. Who calls main? Nobody knows. The system, really. If you run the program, Windows will invoke main, or the system invokes main. And up here, we have another part of the function. This is called the argument list. Most of the time we leave main empty, but have you ever ran a program where you could start it up and then you follow it up with some different variables? Anybody in here play video games? No? No video gamers?
Yes.
Sometimes you've got launch options you can set. If you dig deep, you can go in there and push like dash Vulkan or something like that. You can start a program with different options. And so those options have to come in somewhere, and so they would come in right here. And we would have something like int argc and then char pointer args, which is, I think we did that for SDL, but it didn't work out. Anyways, this is the number of arguments that are coming in. You can have multiple arguments. When I'm talking about arguments, in this case it would be strings or char pointers. So you can start your program with different values being passed in. Anyways, these are called parameters. Not important what they do right there necessarily yet. Just know that these are parameters. This is the return type. This is the name. And this is the function body. So far we've only worked in main, but in most programs you're going to have numerous functions. And you will use other people's functions and you will write your own. So we're going to look at writing our own. We'll do something really simple here. We'll say int. We'll just call it fun1. And function 1 can do something. We'll have it do a simple cout hello world. Hello world. And if I put int here, I will be expected to return an integer of some sort. It can be 0, it can be anything. If I don't want to return anything, and in this case there's really no point in returning anything, you can't just put void up here. Void means we return nothing. Alright, so again, this is our function name, this is the return type, this is our argument list, and this is the body of the function. This is what the function does. So now I've got main and I've got fun1. If I run this program, I expect nothing to happen. The program starts in main, and when main returns, the program is over. Right, so run the program just to make sure it compiles and everything, but you should not get any output. So you get nothing there. We don't see hello world. The function does not run because the program always starts in main and ends in main. So if we want to have this function be part of our program, we call it. And to call a function, you just type its name. Fun1. Functions always have parentheses, so you put your parentheses there, and you put a semicolon. You run that, and then you should see hello world. Any questions? Why would we do that? Sometimes the body of a function could be pretty long. It's like a payroll function or something like that, but I can use this function as many times as I want. All I have to do is call it again. So if I copy and paste it a few times, and run it, it's a lot easier to type that function than to type the entire body of the function. So that's one of the reasons you can write functions. It saves you time. It's like a quick way of accessing a lot of tedious code. Another thing, it allows you to organize your code. Let's say we're doing the payroll program, and we'll call this function getInfo. We can do a cout, enter name, cn, name, cout, enter rate, cn rate, cout, enter hours. Now what do I have red there? I don't have variables for these guys yet. So if you want, you can create variables in your functions just like we do in main. We can have a string for name. We can have a float for the rate and the hours. And basically anything you do in main, you can do in this function. And let's pretend we're not handling overtime, but we can do a quick calculation here. Put gross pay is rate times hours. Set precision. Okay, now if you run the program, what do you expect to see?
So far, nothing.
Nothing, right? We don't call this function, it doesn't run. We get absolutely nothing. But if we do want to call it, how do we do that?
GetInfo.
Call getInfo. Everything's case sensitive with parentheses there. And let's say I just had more than one employee I needed to process. I could put this like in a for loop or something. And I can call get info how many times there? 3. Why is my math all jacked up? Just because I put a decimal? Did something wrong. I set precision 2. Oh, fixed. Maybe that's why. Bob, $10 an hour, 40 hours a week. Yeah, $400. So that works just fine. And it's called the function again because it's running in a for loop. It will run 3 times. We can, let's see, Mary, $10 an hour, 23 hours. And Sarah, $29 an hour, 30 hours. Boom, we calculated everybody's payroll in a fraction of the time because we just had to write this once. And then we can call that function as many times as we need to. You know, you could easily do this for 300 people. And that's a lot less code than writing it out like you did before. Does everyone understand the benefit here?
Yes, sir.
Maybe? I don't feel it. I think you're joshing me.
Oh, I got it.
Alright, he's got it. At least one person's got it. Okay, let's not print out. Let's not print out the gross there. Let's calculate it and print it out in main. So here I'm going to have a float called gross. And I'm going to see out the gross. This is kind of trivial, but I want to make a point. So this will print it out. Now how do I get these calculations into this variable?
Set up an argument in the void function.
We can send it up. We can return something other than void. Let's return something other than void. We'll do it this way first. What are we going to return if we're going to return the gross pay? What data type?
Float.
Float. And here, instead of doing a cout, we will say return. Rate times hours. Or if you want, you can break it down like this. You can say float gross equals rate times hours, and then return gross. Now it's important to note that this gross up here in this function has nothing to do with this gross. Okay, these are 2 totally different variables. The computer will assign them different places in the memory and will keep track of them separately even though they have the same name. But because they belong to a different function, it sees them as totally different. Alright, so we're going to call getInfo and we're going to return the gross. How do I get that in here? Any ideas? How do we call the function? We call the function by name, like that. And when it returns, it will return the gross right here where I'm calling it. So based on that information, where would you put this to assign this gross to this variable? Anybody guess? Everyone's lost. We can just say gross equals get info. When the computer gets here, it will call this function. It will come up here and do its thing. And then when it's done, it will return this value. When it returns, you can basically do a copy and paste right here if you want to imagine it in your head. Let's say it returned 100, then this would become 100. Now we see gross equals 100, that makes sense. Right? So we're going to call the function, it will do its thing, and it comes back with that number. It assigns it right here, and then we'll do the cout statement. So let's try that. Okay, Bob, $10 an hour, 30 hours. And we see gross pay is 300, and that comes from Maine. We don't have this line up in our function. So that's how you return a value. You don't have to store it in a variable. You can call this function and just discard the information. So if I don't have any variable to stick it in and I call the function, that will still work. It's just that the value is lost. So what would you expect to see here? It didn't run. Why is it not running? Uninitialized local variable gross. It wants me to initialize it. I'll start it at 0. So enter name Kate, $30 an hour, 30 hours a week. Gross pay is 0. How's that? You understand what's going on? Or are you confused?
Well, this the cout's using the initialized gross, not the function.
Right. We didn't store the information that came back. So what we get is just the 0 we put there. If we want to use this function, we would have to assign it to gross. So you can do that all in one go, like that. That would work. Or we can scrap that variable altogether. If you don't need the variable to store the information, you can call the function right here, get info. You can call it in line just like that. It calls the function. It's kind of like, what does that tell you right there? Does this read left to right or right to left? Why don't we see gross pay here? Yeah, it called this one first, so it must be reading this right to left. It calls get info first. So we'll put our name in. And it says gross pay equals 600, and that works just fine. Most of the statements, unless there's special order of operations, most stuff gets read from the end over to the left, kind of opposite the way you would read it. So yeah, it calls get info first. Info returns the number, and then it says gross pay equals whatever number came back. Cool. There's a lot of stuff on functions. Another way we can do this, I'll go over one more thing and we'll call it good for today. We'll pick up the rest of this on Wednesday. Otherwise, you'll just get information overload. I'm going to put my float back up here. Instead of gross, I'm just going to call it G because I want to show you that these are different variables.
Yeah, I had a quick question before we continue. So whenever I run the program, it's making me put in the name, like it's making me do it twice before it gives me the gross. I'm not sure. It looks the same as yours. I'm not sure what.
Now we all know that is not true.
Well, I don't know what I did wrong, but it's like making me. It's like.
Okay, we've got a variable called gross, and we're not going to return anything by this function. It's going to be a void function again. So here's another way of doing it. We've got our variable in main, but we got to get it up into this function somehow. So like I said, you can pass this stuff around using an argument list. We can say, hey, we want to send a float up here. Float, and you can call it gross or you can call it anything you want. It doesn't matter. And then when you call getInfo, you are required to provide a float. And because this says this function requires a float to be passed to it, you have to provide a float when you call that function. And you can do it directly. You can do something like that. Or we can use a variable. We have a variable, so let's use it. These are both called gross, but they do not have to match. Now, when I call this function, I send this variable up there. What's in there right now? Nothing. We send nothing up here. It's actually garbage. We send garbage up here. Does this even run? No. It doesn't like that. It says uninitialized local variable gross. Let's go ahead and initialize it again. Okay, it's a 0. We send a 0 up here. And this gross, which is a different variable, takes on a value of 0. Now, it makes a copy. It's important to know this makes a copy of this variable when we call this function. And so up here we have a copy of gross. We do our thing. We can say gross equals rate times hours. But because this is a copy, it does not change the one in main. So what do you expect to see for output? Anybody want to guess? 0. 0 is a good guess. Because we worked with a copy up here. We said it. We said gross equals rate times hours. And this was a 300 or whatever. But it doesn't affect this one down here in main. Because gross was a copy. Now, what if you don't want a copy? You're like, I want to send the real deal up there and I want it to change the one in main. There's a simple change. You put an ampersand on the end of that float. The ampersand is the address of operator. Remember, every variable has an address in the memory, a place where it resides. We send the address up there, it knows how to reach this guy in main. So now, if we run the program, the function does affect this variable. This is not a copy. And we will get an output down here that matches our math. So there's our 30, there's our 40, and then we get a 1200 for output. Just because of the ampersand.
What does the ampersand do again?
It sends the address. When we call this function getInfo, we're giving it a variable, right? Well, before we were sending a copy. Say, hey, gross is 0. Take a copy of our 0 and work with that. Now we're saying, here, take the address of our variable and work with that. And since it has the address, it affects the original variable.
I see.
Otherwise, the copy will have its own address. And when a function closes, when this guy ends, all the information inside of it is destroyed. It actually becomes unreliable. It may still be there and it may not. That memory is kind of open for any other program or even our program to use again and use differently. All right, so we have two different ways of passing. We pass the copy or we pass the address. If we're passing a copy, that's called pass by value. So here, pass by value. Same as passing a copy. And if you include the ampersand, you're passing the real deal. This is called pass by reference. Sometimes you want to work with a copy. You don't want to mess up your stored data there. Sometimes you need to work with the original so that whatever you're doing to it sticks with it. So make a note of that, pass by reference or pass by value. And that's another way we can get our output down in main based on the work our function did up here in getInfo. Pass by reference. All right, that's all I'm going to cover today. There's a lot more stuff with functions, and functions can get pretty complicated. But that's a simple introduction for today. We'll do more complicated stuff on Wednesday.